Corrosion is an electrochemical process that occurs when two dissimilar materials, in contact with each other, interact in the presence of an electrolyte. This often involves metals and the corrosive liquid, typically water with charged ions. In a galvanic cell setup, we see one metal acting as the anode and another as the cathode. The anode undergoes corrosion while the cathode remains intact. Higher negative charge defines the anode's potential. Metals are ranked based on their electrode potentials, creating the electromotive force series. The metal higher in this series becomes the cathode, and the lower one the anode during corrosion in a galvanic cell. Taking aluminium and magnesium as an example, aluminium is more cathodic compared to magnesium. When both metals are in contact with electrolyte, magnesium undergoes corrosion while aluminium stays unaffected. The corrosion process involves electron movement from the anode to the cathode. For this flow to happen, both must be in contact and surrounded by the conductive electrolyte, completing the electric circuit. As the anode loses electrons, it forms positively charged metal ions which dissolve into the electrolyte. For aluminium, the reaction releases aluminum ions into the fluid, causing degradation of the metal surface. The lost electrons from anodic reactions move to the cathode, where they react with ions in the electrolyte, such as positively charged hydrogen, producing hydrogen gas but leaving the cathode metal intact. For corrosion to take place efficiently, three conditions must coexist: two dissimilar materials, anode and cathode, an electrical conductor between them, and a suitable electrolyte like water. Preventing corrosion in aircraft components means disrupting one or more of the necessary conditions. Understanding how these elements interact can help in designing effective prevention strategies. Corrosion isn't one-dimensional. It manifests in various forms like general corrosion, galvanic corrosion, pitting corrosion, and more, highlighting the complexity of corrosion in metals. Thank you for watching. Remember to like, comment, and subscribe.